This is the bottom of the mixer looking from the top, and you'll see that the machines are made with a tangential shape on the hub. And that creates the action that you see with the product going up the side wall and back down into the bottom. Some of the competitors use a kind of a star-shaped impeller. And the problem with those star-shaped impellers is that it creates a dead spot in this place right here, material that's not properly processed. And that's why the tangential shape of our mixer is very advantageous as far as the mixing capability. We have full torque by virtue of the fact that our machines, on the larger machines, we use a hydraulic drive rather than an electric motor drive. And the advantage of that, once again, high potency products, if you're going to transfer the product from the mixer directly to the fluid bed via vacuum transfer, you can't unload that mixing bowl rapidly. You have to do it slowly. Otherwise you overpower the system and you can't affect the transfer. So with the hydraulic drive, we can get down to as little as 1/4 of 1 RPM to be able to unload that bowl slowly so that we can affect the vacuum transfer to the fluid bed. Again, it's an innovation to address the problems created by high potency products and the need for containment. This is a one-pot processor. With high potency products, some companies will want to produce the granulation in the mixer and dry it in the mixer, rather than transfer the product from the mixer to a fluid bed or to trays. And this is to minimize the exposure of the high potency product to the environment and to their employees, and perhaps at this stage in its development, you cannot expose it to oxygen. So a one-pot processor, basically what we do is we build the machine with what's called a water jacket on the bowl, so that we can both heat and cool the product inside the bowl. The second thing that we do is we add a gas stripping. And gas stripping is nothing more than adding compressed air into the system in order to essentially affect the removal of moisture through vacuum pumps. So once we've done the mixing and we've made the dense granule and we want to dry it in the same vessel, we introduce a certain amount of air, we introduce heat, and we will turn the impeller at a very slow rate to drive the moisture off of the product and vacuum that moisture out of the bowl. So the net effect is that we've produced a granulation prepared for blending and compressing in one pot or one vessel. And that's the idea of one-pot processors. Now, I should mention to you that we built quite a number of these. Apotex up in Canada uses our machines extensively for the generic drugs that they make. One of the disadvantages of this is that by introducing the water jacket and adding heat, you can sometimes break that granule down from the granule that you've made for flow characteristics and for the drug delivery. It is reduced back again to powder. So it works very well when the solvents or the product that you're using uses solvents rather than water for aqueous-based uses, because the aqueous-based products, it's much longer drying time in the vessel, has a tendency to break the granule down. So that's what one-pot processors are. By the way, I should mention to you that if you have a question, if something is not clear, please ask, and I'll be happy to try to answer it for you. Okay, fluid beds. From Heischer granulators, generally speaking, a company will take its product to a fluid bed dryer, and here again, over at the FCE show, we have one of our R&D scale fluid beds. And we also make a pilot scale and of course our production scale. The Model 2 that you'll see over at the exhibit has been newly redesigned, and it comes with an Allen Bradley panel view controller for touch controls. It has a built-in, Philip, it has a built-in Watson-Marlow pump. We use Watson-Marlow pumps exclusively with our mixers and with our fluid bed applications. So our product line has as little, you can process in that R&D scale with as little as 10 grams of active ingredient, but more likely with the standard execution of it, it's about a 2 kilo batch size. You can get down to 100 grams if you wish with the same standard bowl. But we do make a variety of options so that you have maximum flexibility for using that R&D scale machine. I should back up a minute and with the mixers and mention to you, one of the things that we have done a very careful job with in preparing our machines is that on the mixers and on the fluid beds you have scale-up factors. So that in the mixer, for instance, the tip speed for all of our mixers is going to be very close from one size to the next, which means that when you're doing your processing in that tabletop machine, you will be able to take some of that information in terms of the RPM of your impeller and the RPM of your chopper and convert that to begin your scale up when you go to the pilot scale and the production scale, which is a very important factor in terms of the uniformity of the product that you're going to produce. Similarly with the fluid bed, and I'm going to show you a slide later on that explains this a little further, but we also have scale-up factors in terms of the velocity of the air and the number of air changes that occur per minute inside the bowl in the fluid bed. So, what are some of the features that you'll see on our fluid beds? First of all, I think that most of you understand essentially how fluid beds function. And a fluid bed is basically an air suspension product. So what we are doing is we have an exhaust fan and we have a conditioning system. So we are going to dry, dehumidify, we're going to heat, and then we're going to mix the air. We're going to run it through HEPA filtering, and then we're going to introduce it into the fluid bed, and the air is pulled through the fluid bed by this fan. So a fluid bed is nothing more than a vessel in which you're moving conditioned air through to dry your product. That's a fluid bed dryer. They all work pretty much the same. And our machines work similar to that of the competition. And we've done a number of things that we think are essential in terms of improving the technology. Let's go back, Mariana, to the previous. Okay. What we're showing here is humidification, the various options for air conditioning. Let's go to the next one. This is Worcester coating, and can I show your hands if you have ever had Worcester coating explained to you? If you know how Worcester coating works? Worcester coating, okay. Most new drug products, when they are approved, are in the form of what they call immediate release active ingredients. So you take a tablet and you may need to take that same medication 2, 3, 4 times a day. Worcester coating provides the means with which you can coat the active ingredient particles to control delivery. So we can put a coating on a particle to affect a drug release over a period of 12 hours, maybe even over a period of 24 hours with one tablet. And that is what the Worcester coater accomplishes. So in a fluid bed, we can do three basic processes. We dry, we can produce a fluid bed granulation, and I'm confident that you know what a fluid bed granulation is. It's basically a top spray granulation that causes the powder to agglomerate in suspension. And then the third factor, or the third use of it, is the Worcester column. And the Worcester column brings the spray in from the bottom. It brings the particle into a coating zone, and it puts a coating on the surface of the particle rather than make the particles stick together. So you put a protective coating around this particle that provides you with the means with which, by the weight addition to that particle, you can control the drug delivery. It's a fascinating technology. And generally speaking, your drug products, the more sophisticated drug products, which you make here in Brazil, will utilize some type of modified release system, and the Worcester coater is one of those systems. We use the two big problems. I should back up for a minute. Two big problems with Worcester coating are the air balancing system. Go to the next one. The air balancing system, which allows for us to make sure that the volume of air that goes through each one of those coating tubes is the same. And the second problem is the buildup of the suspension, if you are using a suspension, on the tip of the spray nozzle. And because we are a division of spraying systems, guess what? We have devoted a lot of energy to producing a spray nozzle that eliminates that bearding factor. Because if you have improper distribution of air in your coating tubes, some tubes are going to see a lot of product and other tubes aren't going to see any product or any air volume, and they're going to end up with all the product stacked up in there, and you're going to have a wasted batch. So we have two big problems: air distribution and the clogging of nozzles. And we've solved those problems through the technology of the air balancing system and also with the anti-bearding spray nozzle design from Spraying Systems. Okay. We make a number of distribution plates. This one happens to be the TurboFlow, which is kind of a basket weave design. Most of you who are familiar with fluid beds are familiar with the bed bowl. It has a screen on the bottom that is much like the screen that you put on your house to keep insects out. And those screens are very difficult to clean, and they're also subject to ease of destruction in cleaning. So the TurboFlow screen, it's a basket weave design where the air comes through the horizontal rather than the vertical axis, and it's solid stainless steel, so it can actually be scrubbed with a wire brush for cleaning. The second advantage of that screen is that it creates pressure drop across the bed that eliminates what are called dead spots in the bowl.